Okay, good evening, ladies and gentlemen, and welcome to this day two of Green Belt Certification Hackathon. So, if how are you? If I ask you, how are you? How will you describe right now? Just type in one word. How will you describe yourself in one word? What will be that word? Type in the chat box. Okay, amazing. Keep typing. Keep typing. Yes. Now you can. Now you can. Enthusiastic, awesome, amazing, curious, energized, active and fresh. All right. और बाकी लोग किधर है? Everybody type your current state of mind right now. Fine. Okay, fine is also good. What else? What else? Nobody's tired. Nobody's uh okay. ड्राइविंग करके थका नहीं है कोई, ट्रैफिक में फंसा नहीं है कोई. Fantabulous. Tired. Okay, so I finally got somebody who is tired. Thank God. I thought you guys are just woken up and attending the session. All right, chalo. So let's do a recap. There is a rule called 86-14 rule. How many of you are aware of 80-20 rule? 80-20 sabko pata hai? Just give me yes in the chat box. 80-20 everybody knows. Yes, it's a Pareto principle which we are going to do some practical today. Okay, but do you know 86-14 rule? Have you heard about 86-14 rule? Have you heard about it? 86-14. Instead of 80-20, it's 86-14. Have you heard about it? No, right? Okay. So the rule is about the memory. Now, this is a very fascinating, very interesting rule. Listen to this. This is the rule about our memory. Okay. So whatever we learn during the day, let's try to understand this. Whatever we learn during the day, learn meaning whatever we read, whatever we see, whatever we comprehend, whatever we learn, whatever we conceive in our mind. Okay. 86% of that flushes out before we go to bed on the same day. Wow. I repeat again. Whatever we learn on the same day, 86% goes away. We do not store it in our memory for a very long time. So what does it mean? It means whatever we have learned yesterday in last 3 hours session, evening, okay, 86% we have already forgotten. You want to check this hypothesis? Okay, chalo, let's find out. Can you tell me what tools did we learn yesterday? Type in the chat box quickly. What kinds of tools, techniques, topics we covered yesterday? Chalo. You can refer your notes, by the way. You don't rely on your memory. Okay, fantastic. So Kano model we have seen, SciPoc we have seen, then statistics. Okay, we have seen statistics, define phase, descriptive statistics, inferential statistics, Pareto we have just spoken about, but today we will see that in details. Racimetrics, types of data, mean, mode, median. Okay, yield, SWOT analysis. Okay, so external way of identifying projects, internal way of identifying projects, voice of customer, voice of business, voice of design, specification limits, target, what is the definition of defect, what is defective, what is defect. We have seen everything yesterday. Yes, no? Correct? You remember this? Everybody remember this? Yes? Amazing, amazing, super. Okay. Now the moment I ask the question, okay. So the first point, first question comes into picture. Okay, what was that? Yesterday we kya sikha tha, right? Okay, so 86-14 is a memory rule. So how do we recover the remaining 86%? Is through recap and revision. Okay, so always remember. So whenever we start a new day, always we will do a quick recap like whatever we have done right now today. Okay, so today, right now we are in which phase? Which phase we are covering right now? Type in the chat box. In the DMAC principle, which phase we are in? Everybody? Super. We are in the major phase. Absolutely right. We are in the major phase, right? Chalo. So in the major phase, so let's find out. There is something called operational definition. Make a note of this. Operational definition. Now, what is operational definition? Let's try to understand this. When we try to collect the data in the major phase, see, in the major phase, what we do is, first we understood what types of measures we have: input measure, process measure, output measure. What types of data we have: continuous data, discrete data, correct? And what kind of so it's all about data basically. Okay. Now, when it comes to data, then before collecting the data, there are two important points basically we check. First is operational definition. Operational definition, I'll just give you a background of that. Okay. Imagine the aviation ministry. Okay. Aviation ministry wants to check which airline has the most, what you can say, highest percentage of on-time takeoff. What is that? On-time takeoff. What does it mean? It means, let's say, if the flight time is 7 p.m. or 7 a.m., how much, are you taking off at 7 a.m.? Okay, so they ask, the question to, let's say, Indigo. Let's say we are talking about the domestic airlines, okay? And they speak to Air India, okay? And they speak to maybe Akasa, okay? And then they speak to, what is any other airline right now? So Jet Airways and Kingfisher are gone, right? Which will just give me one more. SpiceJet, okay? SpiceJet hai kya abhi bhi? Okay, chalo, SpiceJet. SpiceJet. Air Asia, okay. हाँ, SpiceJet साउथ में है क्या? Okay, okay, okay. Good. Vistara, okay. Yeah, Vistara is, I just forgot Vistara. Anyways, come on. So Indigo, Air India, Akasa, and SpiceJet. Let's say 4 airlines. Right? These are just examples we're giving. Now, Indigo says, now just try to understand that this is on-time takeoff. On-time takeoff, we want to check. Now, Indigo says, when my flight basically pushes back from the parking bay, that is our takeoff time. So according to, I'm just giving you example, okay? It's not like Indigo does like this, but Indigo says when my flight, which is basically parked in the bay, when the pilot pushes it back on the reverse gear, it takes it back. That is the time we count as a takeoff time. Air India says no. The moment my plane starts taxiing towards the runway, that is my takeoff time. Akasa says the moment my plane reaches to the runway, that is my takeoff time. And SpiceJet says the moment my plane, it takes off from the land, from the runway, actually takes off from the runway, that is my takeoff time. Now tell me, if I collect the data like this, where is no standardization, okay, will it make any sense to compare all these companies' performances? Just type yes or no in the chat box. Will it make any sense? It will be apple to orange to banana and everything, right? Yes or no? Okay, so what is operational definition? Just try to understand this. Operational definition is to maintain the standardization in data collection. Operational definition is used to maintain the standardization. So what we do in operational definition? Basically, we define what data will be collected, who will be collecting the data, when the data will be collected, okay? Then what frequency the data will be collected, the frequency, okay? How the data will be collected, where the data will be stored, and everything related to the data. Can you scroll it down, please? Okay. Yeah, we can say 5W1H. Okay. So what, who, when, where, at what frequency, where it will be stored after that, everything which is, which is defined, and that is called operational definition. Okay. Now, airline industry standardizes everything. Whenever your plane takes off from the ground, that is your takeoff time. If that is the, the time which they define, so everybody has to maintain that, that kind of data, and then their comparison will make sense. Who is at what percentage level of performance? And this is called operational definition. Are you clear with this? Just type yes in the chat box. Are you clear? Just give me yes. So before we collect the data, we standardize everything. What will be collected, how it will be collected, who will be collecting this, what frequency it will be collected, where it will be stored after collection. Everything is standardized in a document, and that document is called operational definition. Just give me yes in the chat box if you have understood this. Then only we should start collecting the data. Clear, everybody? Operational definition. Very good. Super. Now, in your, in your green belt curriculum, there is a template also given, example template. You can refer that template. Okay. Now, once this is done, so this is the first point. The second point is called measurement system analysis. Okay. Very, very important point. It's called measurement system analysis. Now, how many of you are right now? Now we are in the January, and this particular week is the week of resolution. Okay. So tell me, how many of you have taken resolution this year to reduce your weight? Just type me in the chat box. How many of you have taken the resolution? Yet, yes, salto, pura, I will reduce by 5 kg, 10 kg. January, May, everything is on the top, right? And then we do some charity to the nearby local gyms. Okay, I'm also not the exception for this, by the way. All right. Okay. So then we give the charitable fees, and we never go there frequently. January the gyms will be full. February it will reduce, and if I draw the draw the time series plot, it will be crashing down. The moment December comes, it crashes down again. It goes up. Okay. Anyways, coming back to this now, let's say you are in the weight reduction program. Okay, and you are very you are taking care of your gym, your exercises, your yoga, your food intake, okay, diet plan, everything. So you're following exactly to the T. Whatever the doctors and the experts are basically giving you the plan, you are following it to the T. Now, what is happening is, let's say you are, whenever we are doing such kind of thing, we are very curious to check the result, right? So such cases, we basically check our weight very frequently. Okay. Now imagine, let's say your weight is 75 kg. Just imagine your weight is 75 kg. And because of this diet and exercises, you want to reduce it to 70 kg. I'm just giving you an example. Now, but because of this, instead of reducing, if your weight is increasing, what will you do? Type in the chat box. It has become 77 now. What will you do? Type in the chat box. Ab kya karoge? You have followed it everything for maybe 2 weeks, 2 to 3 weeks. But instead of going down, it is going up. What will you do? Okay, so demoralize. Okay, you will be demoralized first. That is very honestly, yes. It will be frustrating. It will be demoralizing. Moralizing, yes. Then change the workout. Then what else? Improve the diet. What else? Yes. See, senior members are giving the right answer. Okay. The people who know the answer. Stress management. Okay, fantastic. Now, whatever you have done earlier, okay. Now, the first thing, what statistics says, what Six Sigma says, check the weighing balance first. How many of you have got the bulb on moment right now? Before you attack on your processes, okay, before you attack on your processes, which is your diet, your exercises, everything, and do it even harder, first check the weighing balance, whether is it calibrated, is it working well, or is it imbalanced already. Are you understanding? So this phenomena in statistics, it's called measurement system analysis. Make a note of this. It is called as MSA. MSA. MSA stands for measurement system analysis. Write this down. Measurement system analysis, MSA. I should write here. Measurement system analysis. Okay, MSA. Now, MSA, if you have continuous data, I will just give you two ways. So in MSA, basically, what is MSA? MSA is nothing but quantifying how much variation is induced by the measurement system. For example, if this is the total variation of the process, every process is a total variation. Okay, yesterday also we have seen the bell-shaped curve, the histogram yesterday, right? Today we will draw histogram in Minitab. Now this total variation, how much variation is induced because of the measurement system? Okay, if this is the total variation, let's say, and this is because of the measurement system, MS, okay? If this measurement system variation is less than 10 or less than 10, then it is acceptable, okay? If it is greater than 10, then you need to basically check your measurement system. Okay, this is the simple fundamental of measurement system analysis. And how this 10% will be quantified, there is a process called measurement system analysis. That is what I'm just speaking about in this. Okay, clear hai? Yeah, it is percentage. I'll explain you what is that. Now, so in MSA, there are two parts. If you have continuous data, then we follow, you can just make a note of this. We follow gauge R and R, GRR, write this down. And if we have discrete data, then we follow AAA. AAA stands for attribute agreement analysis. If you have continuous and discrete, yesterday we have seen that continuous data, discrete data, right? So whenever you have continuous data, we follow GRR. GRR stands for gauge repeatability and reproducibility. Okay. Yes, 10% of the total variation. Exactly. Yes, you can say that. 5% on the either of the sides. Perfect. You can say that. Okay. Now, GRR, gauge R and R, which is gauge repeatability and reproducibility. And the other one is called AAA, which is attribute agreement analysis. Okay. In the green belt level, we have just a theoretical awareness about this terminology. Okay. In the black belt level, we go deeper into how this is conducted practically with some Minitab exercise, etc. We will check that. Okay. But at the green belt level, some awareness level is there. Okay. So now what is GRR? Now this terminology is decided by a body, a global body, which is called as AIAG. What is AIAG? AIAG stands for Automotive Industry Action Group. Just for your information. Okay. Automotive Industry Action Group. Now, this is a body which publishes, okay, these standards required for the automotive industry, predominantly in USA, and this is followed by the other countries as well. Okay, there is another body called VDA, which is used in Germany, but AIAG is followed across the globe. Okay, Automotive Industries Action Group. Like, you have for 9001, ISO 9001. So ISO is a body, right? The global governing body. Similarly, AIAG is a body which basically gives the standards. Okay. So according to AIAG, okay, what is repeatability and what is reproducibility? Just try to understand this. Okay. What is repeatability? Yeah. So repeatability is Repeatability is, let's say, imagine I want to check the diameter of these kinds of, let's say, pen. Okay, I want to check the diameter of this pen. So what I will do, I will take 10 such pens. Okay, 10 such pens. I will take vernier caliper or the screw gauge, whatever, just to measure that diameter. And I will take 3 people or 3 quality checking personnel. Okay, and those we can call them appraisals. Okay, so 10 samples. So what repeatability means? The same sample, let's understand this. You can write, I will explain you. Same sample with the same equipment. Same equipment. Equipment meaning the vernier caliper. Okay. And the same person. For example, okay, I take this pen, I check the diameter of the pen, and the pen diameter is, let's say, 10.1 mm. Okay, 10.1 mm. I take the second reading after some time. Again, it comes 10.1 mm. I take another reading. Again, it comes 10.1 mm. If I am repeating the readings all the 3 times, then it is called repeatability. Repeatability meaning same sample with the same vernier caliper, I am giving the same reading by the same person. It's called repeatability. Are you clear? Just type yes in the chat box. Just give me yes. Clear hai? Very good. The next one is called reproducibility. Reproducibility is the same sample plus the same equipment, but different person. It's called reproducibility. That means the same pen diameter, if I take, it is 10.1. Let's say the same reading, if the other person also gives, that means it is called reproducibility. Very good. So repeatability is the variation due to gauge, and reproducibility is variation due to the person or the operator or the appraiser. Are you understanding? So repeatability basically is showing us the variation coming because of the equipment, and reproducibility is showing the variation coming because of the people to people variation. Now, people to people variation meaning their understanding, their eyesight, their accuracy, precision, whatever detailing because of the person. So repeatability and reproducibility, this is what is checked. Okay, so there is a procedure in which we take 10 samples. So we take 10 samples. 10 samples. Okay. And 3 operators. 10 samples into 3 operators, and every operator takes reading 3 times. That means if I take reading, I will take for every sample, I will take 3 readings. Okay. So there will be 3 readings. That means total 90 readings will be there. 10 into 3 into 3. Total 90 readings. So this data set, we put it in the software, and software will give us a value called GRR value. Write this down. Software will give us a value called GRR value. Okay, GRR. So it's in percentage. Okay. In the black belt level, we will do it practically on the Minitab with some practical data, so that will be more clearer. But at the green belt level, just the awareness about this is good enough. Okay. So in the GRR value, if it is between 0 to 10%, it is excellent. If it is 10 to 20%, needs improvement. No, 10 to 30%. Okay. needs improvement and above 30%, you need to reject the scale. Reject the scale meaning either you need to change the people, retrain the people, change the equipment, and do this entire study once again till the time it is coming below that 10%, it's best. Okay. Even if with some deviation up to 30%, it can consider it is depending on the sector to sector. Okay. Industry to industry. But if it is above 30%, then you have to reject the gauge. And this is called the measurement system analysis. Okay. When we will go, when we'll go deeper into the black belt, I will touch upon each and every detailed point of this. All right. Yeah. Both repeatable. Yes. Actually, what we do is we take the 10 samples. Okay. Rajivji, we take the 10 samples. Okay. And every person randomly now, the person who is conducting this experiment, who is extra from these three. Okay. So that person will randomly provide these samples to them, and those people will take the readings and give the reading to that person. Okay. So after this, every reading is taken, then we put that reading in the software. And there is an analysis procedure we follow in the software Minitab. Then Minitab will give us the GRR value. Apart from GRR value, there are certain values which also have to be checked. But as of now, you can understand this. If the variation is less than 10%, it's an excellent gauge. Here, yeah, both the data, repeatability and reproducibility, both the data is be taken. Repeatability, because you are also taking the same reading again and again 3 times. It is repeatability. And reproducibility meaning the other people also are taking the reading, right? So reproducibility is other people's reading comparing with each other. Okay. So both of them are basically considered. Okay. Now GRR calculation, there are formulae to calculate the GRR percentage, but at this point in time, they are not required for us to do it manually. Okay. If required, we can do it manually. Maybe at the master black belt level, we can learn it manually. Okay, we can do it manually as well, but it is time-consuming process. Right now, we don't have that much of time to do it. This statistics is very fascinating. Okay, what happens is if you go deeper, that's very good. But we should basically try to focus on one thing, which is problem solving. We are part-timers in this project. Okay, in the green belt level. Okay, so we need to make sure that we have whatever limited resources we have, right? We have to take the maximum output out of it. Okay, why 3 readings? Because then we can compare between. Let's say if we take only 1 reading, all right. If we take only 1 reading, that reading, if there are certain factors which are influencing that reading, we will not be able to do it. Okay, even if you take 2 readings, then also. So 3 readings are generally, you can compare and you can take the mean of these 3 readings. Okay. So generally it balances out some factors which have influenced the reading, etc. That's why they actually take the 3 readings. Okay. Yeah, definitely. And in our master black belt curriculum also, lot of concepts we have already given. It is, in the pre-recorded stage, lot of concepts in depth you can identify. Okay. Chalo, are you clear with MSA? This is what MSA is all about. Just give me yes in the chat box. Clear hai yahan tak? So that we will go ahead and minimum 3 readings. Yes, minimum 3 readings. Very good. Chalo. So everybody has Minitab with them. Can you just open the Minitab? I'll give you some files, and we will practice on those files. I hope everybody has the Minitab with them. The people, who don't have Minitab, the new people. How many of you don't have Minitab yet? Okay, the members. I'm asking to the members. Okay, if you are an invitee, if you have an invitee, okay. Saurabh, for you, this is the So this is the procedure. Yes, Omana, this is a procedure. You can just follow this procedure. It is already given. When you join SNG, okay, the day 1, you receive the number of messages. Okay. So in those number of messages, this is one message of how to access this Minitab. Okay. So I would highly recommend you guys go ahead and do that. If you don't have Minitab right now, don't worry. Just observe whatever we are doing, and you can just do it, download it, and access it later. Meanwhile, let me just quickly. Yeah. So let me share a file with you guys. Okay. Let me share a file first, and we will directly start with Minitab. Okay. चलो Minitab से शुरुआत करेंगे. And here is my file number 1. Okay. Yes. Can you see a file there? Can you just download a file which is there in the chat? Okay. Chat में आपको एक file दिख रहा है which says process capability normal. All right. Just click on that. It will get downloaded on the laptop. Now, for Minitab, you either require a desktop or a laptop. Okay. Even any older version also is, yeah, both are the same files, Rajiv ji. Because some of the people are not receiving it. Okay. जो लोगों को फाइल रिसीव नहीं हो रहा है ना, जस्ट अपडेट करिए आपका ये. ओके. आपका जो ये है ना, जूम को थोड़ा सा अपडेट करिएगा. कभी कभी ओल्डर जूम वर्जन में फाइल शेयरिंग में थोड़ा इश्यू आता है. ऑलराइट. यस. सो मीनवाइल द सेम फाइल let me just check if it is there. Okay. Let me check this. The same file is available in our green belt level as well. Let me just confirm that quickly. Just a second. Which is the file? So I'm just figuring out where is that file. Okay. Okay. Any other people, have you opened up this? No, WhatsApp पे नहीं होगा वो. WhatsApp पे वो जाएगा नहीं file because it's a Minitab file, so it will not open on WhatsApp. I'll share with you. I'll share with you. Don't worry. I'll give you a way out of this. Okay, let me just figure out where is that Minitab file. Okay. Just give me a second. कहाँ गया? ओके. चलो इसमें ही देख लेते हैं. ग्रीन बेल्ट का ये ओपन करिए. उसमें ग्रीन बेल्ट का ओपन करिए. उसमें देखिए there is a green belt hackathon. Let me share my screen, by the way. It's a green belt curriculum. Everybody, just go to green belt curriculum. Yeah, no issues, Sagar ji. Yeah, so in the green belt curriculum, there is a hackathon recording of the last time. Okay, so in that day 2 mein jaiye, click on start. The people who are not able to download it, okay, go to our green belt curriculum. Just scroll it down. There is a green belt hackathon recording of last time. Day 2, go to day 2. Just below that, just download this file. Process capability normal. Can you see this? This one, the first one. Just click on that. It will get downloaded. Everybody. Green belt. Click on our course 1 green belt. Scroll it down to the hackathon recording. Day 2. Day 2 may below the recording of this day 2. You can just check this. Clear, everybody? Just give me yes in the chat box. Open होने के बाद, the people who are not able to see the file in the chat, उनके लिए ये option बता रहा हूँ. The same file we are using right now. Done, everybody? Just give me yes in the chat box. Done, 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 done. Team, can you scroll it down, please? ओपन, फंटास्टिक, सुपर। ओके, होने के बाद चलिए, सो let me open as well. Okay, open. So this file, understand this. This data is about a chocolate company which is making chocolate. Okay, so the output is the chocolate weight. Okay, now what they're doing, they are just taking the weight of the chocolate. Okay, so are you getting this weight of the chocolate? मैं share करता हूँ मेरी file, very screen right now to you guys. Everybody can see this? Yes, very good. Okay, now let's do one thing. Go to stat, basic statistics, graphical summary. Just follow this path, please. Stat, basic statistics, graphical summary. Okay, everybody with me? Stat, basic statistics, graphical summary. Click on that. In the variable, okay, in the variable, just double click on chocolate weight. I repeat again. Go to stat, basic statistics, graphical summary. Stat, you will find out in the menu, the fifth option, stat, basic statistics, graphical summary. In the variable, just double click on chocolate weight and say, okay, don't do anything else. Sridhar ji, which Minitab version are you using right now? Which Minitab version are you using? Just a second. Yes. For Tuhin, this is the just observe this. How to access? Just observe this, so you will get it. Okay, it's in the green belt level only. You will find out. Just after define phase, you will find this option to access this. All right, everybody got it? Now the people who don't have Minitab, just observe whatever we are doing. Okay, clear? Just give me yes in the chat box. Now just try to understand this. Just try to understand this. Okay. The first one. What is this diagram called as? Type in the chat box. What is this diagram called as? This diagram. It's called as what? Fantastic. It is called as histogram. And this red curve is called a bell-shaped curve, which is connecting that histogram. Correct? Now, this is called the mean. You remember yesterday we all discussed about the mean, mode, median, etc. Correct? So this is mean, which is 42.1. So the average weight of the chocolate is 42.106. Okay, the people who don't have Minitab or any challenges, observe here. This is more important. You can just do it later. Okay. The next one is called standard deviation, sigma, 1.645. So on an average, so let's say if I draw a line, the center line here, on an average, every chocolate weight is 1.645 grams away from the mean. That is what standard deviation is all about. Then it is called variance. Variance is nothing but sigma square. Remember variance? Sigma square. Then we take the square root of that. That becomes the sigma, standard deviation. Correct? Okay, skewness and kurtosis we will see later. Skewness, if you remember, yesterday I spoke about something like this, a skewed distribution. Remember that? Skewness, how many of you remember? There is something called normal distribution, symmetrical, and there is something called skewed distribution. So skewness basically talks about it. Okay. Anyways, n is equal to number of data points. So in this data set, there are 120 data. N is equal to number of data points. Okay, clear? यहाँ तक clear है? Now after that, this is minimum. What is minimum? The lowest value of the data set. Now, how many of you remember the yesterday's cake? Cake किसको याद है? कल का cake किसको याद है? How many of you remember yesterday's cake? When we cut the cake into 4 equal parts, right? So this is the minimum value. Okay. The second one, the first quartile. This one is my first quartile. Okay, Q1. We can say Q1. Then this is the second quartile or median. This Q2. And the Q3 is the third quartile. And the maximum. This is the maximum value. How many of you got this? Just type yes in the chat box. Sridharji, you got the data? Fantastic. Super. Now, can you correlate with this? Okay. Now, this everything is called as, this entire part is called as descriptive statistics. Remember descriptive statistics? Statistics. Okay. And this part, a little part below here, it's called as inferential statistics. Let's try to understand this. Now, what is this? 95% confidence interval for mean. Just try to understand this. What does it mean? Okay. It means with 90. Now, this is my data from my sample. Sample of 120 chocolates. Now, what I'm inferring? Okay. Now, understand this. My mean is 42.106 with 95%. Don't know first two parameters. Could you please explain? Yeah, this one, na, A squared and P value. Yes, I will explain that. I'll explain. Okay. Now, the 95% of the confidence interval of mean, what does it mean? You remember population and sample? Yesterday I spoke about population and sample, correct? So all the students of SNG are the population and the students present in the classroom are the sample, correct? So with the sample, I'm predicting about a population. So what I'm predicting, with 95% confidence, I can say that the mean of the population will lie between 41.808 and 42.403. And there is a formula to calculate it. There is a formula to calculate it. Understand this? Okay. The same goes with the median. The median here is 42.1, right? 42.1. So, yeah, so median is 42.1. So what we are saying, with 95% confidence, the median of the population will lie between 41.58 to 42.32. And same goes with the standard deviation. Are you clear? And this is called inferential statistics. Clear everybody? Just give me yes in the chat box. यहां तक समझ में आया है? Yeah, descriptive is clear. Everybody, descriptive is clear, right? Inferential is about the population. Inferential is about the population. Okay. You know, it's like astrologer. Okay, we go to astrologer, hamari kundali dikhane ke liye, right? So what astrologers people will say? They will say that, okay, let's say if you are you're looking for marriage. I'm just giving you example. If you know, you are going to get married, your marriage will happen on 26th year. Okay, between 26th and 27th year. That is what the astrologer will tell you. Astrologer will never tell you 26th year, 5 months, 2 days, you will be married. No, there will be a range given. Okay, iske aur iske beech mein hoga. Similarly, this 95% confidence interval is a range given as a inferential statistics, and there is a formula to calculate it. Okay, clear hai? All right. Now, look at this. This is a histogram. What is this graph, by the way? Okay, what is this graph? This graph. I'm talking about this graph. What is this graph? Everybody? Yeah, this is called box plot. Everybody make a note of this. The people who are not aware of this is called box plot. Now, what is box plot? The same histogram can be depicted as box plot. This is the minimum value. The same thing, the cake. This is the cake. This is my quartile 1. This is my quartile 2 or median. This is my quartile 3. And this is my maximum value. How many of you got this? Just type yes in the chat box. This is called the box plot. Clear? So you can draw the box plot vertically as well. How you can draw the box plot vertically? Let's go to box plot. Go to graph. Let's draw the box plot vertically. Go to graph. Go to box plot. Okay, select the simple box plot as of now. Say okay. Everybody just go to graph. Just click on graph. And the middle, in the center, you will find an option called box plot. Just click on that. By default, simple will be selected. Just click on OK. Just select the chocolate weight and just say OK. You can see here, both box plots are actually same. One is horizontal and one is vertical. The values are exactly same. Clear, everybody? Clear hai? If the box plot is vertical, more the height of the box. Now understand this, huh? If the box plot is vertical, more the height of the box plot, that shows more the spread of the data. Less the height of the box plot, lesser is the spread of the data. Are you clear with this? Just type yes in the chat box. Are you clear with this funda? If I draw a vertical box plot, if the height of the box plot is very high, okay, then it denotes the spread of the the data is very high. The dispersion, you remember dispersion? Yesterday's example of Rishabh Pant and KL Rahul. How many of you remember? Rishabh Pant had a huge variation. Rahul had a small variation, right? So if I have to draw box plots of them, it will look like this. Rishabh Pant's box plot will look like this. And KL Rahul's box plot will look like this. Are you understanding this? Just type yes in the chat box. Clear hai? The same data can be depicted in a different way, histogram and a box plot. So box plots are basically comparison करने के लिए use करते हैं. So you can compare multiple machines, multiple people, multiple departments' performances, in one shot. 3, 2, 4, 5. Okay. All the, let's say I want to compare all the 10 batsmen of Indian cricket team. What is their performance average last 30 matches? I can plot a box plot and I can check whose variation is very high, whose standard deviation is very high. Are you understanding this? Just type yes in the chat box. Clear hai? Box plot clear hai? Histogram clear? All this inferential descriptive statistics clear? Just give me yes in the chat box. Very good, very good. Okay. Now, let's do, now from this, how do I go back to the data? How do I go back to the data? Now, I just have to click on this. Okay, can you just see my cursor over here? Okay, just observe here where my cursor is on the top. Okay, these 3 tabs are very, very important. What are those 3 tabs? Tab number 1. So look at this area. Okay, This central tab is where the data is there, where whatever data you are working on, this data, you can click here, the data will appear. On the left-hand side, whatever statistical analysis, so this is called sessions folder. Sessions folder. Okay. So whatever statistical analysis you have done, that will be stored there. And whatever graphical analysis you have done, that will be stored in this column. So here, all the graphs will be stored. Clear? So all the statistical will be there in the sessions folder. All the graphical will be on the right-hand side. And in the center, there will be data. Clear, everybody? So wherever you come to, why two data shows in mean and median? Mean and median. Very good, very good. Very good point. Very good question, by the way. Okay. Are you clear? This point is clear, guys? Just give me a yes in the chat box before I take this point. Clear hai ye point? How to go back to the data? Okay. Now the question from Rajiv ji is mean and median. Okay. So 95% confidence level data express. So 95% confidence level meaning it's all about okay. Anyways, when we will go to the hypothesis testing today, the second half. Okay. I will explain you this 95% confidence level. Clear, everybody? Okay. And the hypothesis testing level. So I will not cover it right now. I will cover it at the hypothesis level. Right now, we need to just check 95% confidence level. I will explain the concept at that level. Okay. And the hypothesis level. Otherwise, it will be a repetition. Okay. Now, why two values are showing for mean in 95% confidence level? One is for mean and other is for median. And both are different. 42.106 is mean and 42.100 is the median. Okay. Now just try to understand this. Why mean and median, two different datas are there? I'll give you a classic example of this. Okay. This is just because this question has come. I'll give you 41.80. So see, this is the data what you're asking. This is the lower level and this is the higher level. What does it mean? So if you see here, this one is this. This is this 41.808. And this data is that 42.302. 403. Oh, sorry. Yeah. So what they're saying is the mean of the population will be between this point and this point, somewhere around here. Will be somewhere around these 2 points ke beech mein mean hoga. Okay, that's why the 2 points are there. Clear, everybody? Yeah. Very good, very good. 95% confidence kya hai na, main aapko hypothesis mein, yeah, mean and max. Exactly. It's a mean and max, and there is a formula to calculate. You can also calculate it. Okay. Black belt level mein hum log calculate karenge usko. Anyway, now coming back to data. Okay. Let's go back to the data once again. Let's click on this tab, or the short key is Control-Alt-D. Control-Alt-D. Okay, just click on that Control-Alt-D. So you will come back to the data. Okay. Now, I want to identify the time series plot. Okay, let's say let's do a time series plot. So what is time series plot? Go to graph, and the fifth last is the time series plot. Just we'll make it practically and understand it. Rather than understanding the theory, we will practically do it and understand. Everybody just follow this. Go to graph. The fifth last option is time series plot. Just click on that. This window will appear. All right. Everybody with me? Go to graph. First, open the data. Go to graph. The fifth last option is time series plot. The name itself suggests time series. Okay. So what is your performance against the time? That is what we are plotting. Okay. So let's select the simple, select the chocolate weight and say, okay, don't do anything else. Have you got this? Everybody got this graph? Just give me yes in the chat box. Everybody got it? Just give me yes. The people who are just following on Minitab right now, practicing on Minitab. The people who don't have Minitab right now or traveling, just observe what we are doing. Okay, you can check the recording and practice it later. Now, this is called time series plot. Now we see Nifty index, BSE Sensex, correct? We see that this is nothing but time series plot. What is that Sensex or that Nifty index going, performing against the time? Is it going up or is it going down? It is called time series plot. Clear? Now, just observe this and tell me your observation out of this graph. ये ग्राफ में आपके क्या क्या ऑब्जर्वेशंस है? टेल मी दैट. What observations do you have? Done? What is your observation? Tell me. First 5 sample variation is less. Okay, yeah, first 5 samples, very good. Okay, what else? Minimum and maximum. The trend is flat. Okay, the trend is flat. All right. What else? Just observe. Now, while reading the graph, okay. Now, this graph is nothing but yesterday we learned about voice of process. Remember that voice of process? This is nothing but voice of process. This is how the process is speaking to us. All right. Now, whenever we are observing, just observe that graph for at least for 1 minute, for 60 seconds. Then the graph will start speaking with us. It will start giving us a lot of information. Okay. Very good. Few points out of LSL and USL. We don't know what is LSL and USL here. Amrita, we don't know right now what is LSL and USL. We are just observing that, the performance against time. That's it. Okay. अभी हमें पता नहीं है LSL USL क्या है. Mean is 60. Okay. We don't know what is 60. Mean is 60 कैसे हो सकता है? Mean is the same data. Na? Mean is 42, right? If I draw a line, it will be around 42 only, like this. Average line. Okay. Yes. What else? 46 grams is having highest number of samples. Okay. First half is, yes, that's a very good, observation. The first half, let's understand this. Let's understand this. Okay. If I draw a line here, can you see a lesser variation in this part and higher variation on this part? How many of you are observing this? How many of you can see this now? Yes, that's true. So after 50th data point, 50 or 54th data point, something has shifted in the process that needs to be investigated. Are you understanding this? Okay. So these are very smaller aspects we need to identify what changes have happened in the process so that we need to investigate. Okay, whether there is a raw material change, whether any process change, any season change, customer requirement change, exactly what has happened, that a variation has increased or some new people came in the system. Okay, I don't know the reason. We need to investigate. So these kinds of indicators you can find out with the time series plots. Okay, so you need to investigate why these kinds of peaks and valleys are there. What is the reason of this data? What is the reason of this data? And why there is a sudden drop directly from this point to this point? You can see here, similar kind of trend. From this point, it has suddenly jumped to this point. Similar kind of trend here. From this point, suddenly you have come here. And from this point, suddenly you have gone there. Okay, sudden jerk. Are you understanding? So these kinds of jerks, why? What is the reason? Because if we investigate the reason, we can control the process very well. Okay. And this is called the voice of process. Clear, everybody? So where can you use similar kind of time series plot in your process? Type in the chat box. Where can you use this? Where can you use this? Type in the chat box. You check the variation of the process. Very good. But what exactly will you monitor? Right now, it is a chocolate weight. In your case, what will you monitor there? Type that in the chat box. I am interested in that. Result of the student. Okay. Do you mean to say the marks of the students? You mean to say the marks or the percentage? Okay. All right. Then the cycle time. Now understand this. The x-axis should be the time. It has to be something related to time. Then only it will make sense. Huh? It should be time. Okay. Like time can be, understand it, shift-wise data, day-wise data, weekly data, monthly data. Then it should be time or hourly data, hourly performance. Okay. So on the x-axis, horizontal axis, it should be time. Time can be anything, but it should be time. Then it will make sense. Okay. Yeah, customer satisfaction. Day-wise breakdown. Yes. So daily breakdown. That can be against time. What is your performance on daily breakdown? Attendance of the students. Daily attendance of the student. Exactly. Fantastic. Very good. Clear, everybody? Super clear? Why most students came late at a certain period? Exactly. So from the data, you can identify the trend and then your investigation will start. Then you can investigate that why on certain days there are more absenteeism, why on certain days there are more presentee, etc., etc. Okay. Here, this is called time series plot. Very good. Super. Amazing. Amazing. Pareto analysis, you all know that, right? Pareto, everybody know this? Pareto analysis, right? I'll just give a quick Pareto. Chalo, a quick Pareto kar lete hain. Just for our understanding, एक Pareto analysis मैं करा देता हूँ. Let's open this file of Pareto. Okay, everybody just open this file. Meanwhile, I will also open it. Okay. Yeah. Just click on that and we will just do a Pareto analysis now. And then we'll come back to the same data. And then we will do SNC analysis. I will explain you what is SNC and then we'll go ahead. Okay. चलो, so Pareto का ग्राफ ये ओपन करिए, फाइल ओपन करिए, the file which I have shared with you. Let this file be open. ये जो फाइल है chocolate weight वाला फाइल ओपन ही रखिए because we are going to come back again to the same file. Okay. Yes. Okay. Once you open this Pareto wala file, just let me know. Okay. Let me open as well. Pareto, we have already seen in our yellow belt as well. Okay. But let me just do it quickly. So this is the data of, there are, the fruit exporters. Okay. The pitches, the fruit is pitch. So the pitch exporters, they are finding some defects in the pitch, which is, so what are the defects? The bruised, undersized, rotten. Okay. Underripe, wrong variety, wormy. All these are different types of defects which are there. Okay. So let's do this Pareto analysis. Which one is the highest making defect? So go to stat, quality tool, Pareto chart. Can you just follow this technique? Follow this path. Stat, quality tool, Pareto chart. Okay, once you do that, just click on that. Now in the defect data, select the defects. Now defects are in the problem column, like select the problem column here. What are the types of defects are there? So, undersize, bruise, rotten are the defects, right? And the frequencies, how many numbers of the data are there? So you select pitches lost. All right. And below here, combine remaining defects. So you can click on do not combine. Okay, just click on do not combine and just say okay. Everybody got this? Just type yes in the chat box. Super clear? So if we only focus on rotten and bruised, 76% cumulative defects. If we eliminate these two reasons, okay, 76% of the pitches which are basically wasted can be saved. And this is called Pareto chart, which we already know. This is just a quick glimpse about it. Clear, everybody? Pareto chart. So this is actual number, this is actual percentage contribution, this is cumulative percentage contribution. इसमें कोई भी doubt है, ask me. Any doubt in Pareto? Very simple, but very powerful. Huh? Pareto is the simplest, but the powerful most. Okay. Can this also be done for bigger data? Yes, it can be done for bigger data as well. In the bigger data, I will select this option. I would select this option. Okay, if you go back, I would select this option, combine the remaining defect into category of 95. Okay, this option I will select. I will, do it once again. Okay, if I open the data, this is the data I have. I go to stat, quality tools, Pareto chart. Okay. Yeah, just Anushka and Haribabu, just follow this. Once you open the data, go to stat, quality tools, Pareto chart. Just click on that. Just give me yes, both of you. Just give me yes in the chat box if you follow this. Anushka, are you with me? Okay. Yeah, just Pareto chart. Now in the defect, select the problem. So double click on the problem column. It will be selecting the defects. And in the frequency, select the pitches lost. Okay, just click on do not combine. And click on OK, you will get a Pareto chart like this. Here. Super. Fantabulous. Amazing. You guys are awesome. Okay, guys, done. Just give me yes in the chat. Fantastic. Okay. Chalo, let's go back to the original data. Once again, the chocolate wala data ko open karo. Let's understand a concept called SNC now. Let's understand a concept called SNC. Understood? Yeah. Anushka, it requires a little bit of practice because you are very new in the system. Okay. Initially, it will take a little bit of time, but as you are doing it again and again, it will be very easy. Okay. So, give some time and practice. That's the only suggestion. Okay. Now, just go back to the same data once again. I'm just opening the same data file. All right. So let me open as well. Where is my data file? Yes, the same data file, the chocolate weight wala data file. Okay. Now let's try to understand the concept called SNC. Okay. Everybody type SNC in the chat box. What is that? S, N, and C. Everybody just type SNC in the chat box. Let first this concept sink in your subconscious. S stands for stability of the data, which is done by the control chart. Write this down. I will explain you this. S stands for stability, which will be done by the control chart. Then N stands for normality, which is done by normality test. And C stands for capability. Okay. So we will be doing capability analysis. Write this down. S for stability. Stability we will check with the help of control chart. N for normality, we will do the normality test here and check whether data is normally distributed or not. And then we will go for process capability analysis, where we will find out what is my current sigma level. Remember 2 sigma, 3 sigma, 4 sigma. Likh just have you noted this down? Just type yes in the chat box. Have you noted? Done. Super. Everybody fantastic. Now, as of now, let me just clear it off. As of now, okay. Now let's open this. Let's open this. First, we will check the stability of the data. We will do the control chart. Okay, so go to stat, control chart, variable chart for individual. Just follow this. Just follow this. Stat, control chart, variable chart for individual. Follow the steps. Stat, control chart, variable chart for individual. Right? Done. Just click on that. In the variable, just select chocolate weight and say OK. Everybody got this diagram? Just give me yes or no in the chat box. Got it, everybody? Yeah, where are you stuck? Let me know. I will open it once again. Stat, control charts, variable chart for individual. Just follow this path first. Open the data, the old data, chocolate weight wala data. Okay. Now the Pareto file is open. Pareto file you can close and just open the chocolate weight wala file once again. Okay. Go to stat, control chart, variable chart for individual. Okay. Correct. Now go to individual. Now just select chocolate weight over there and just click on OK. This you will get. Got it? Sagar, have you got it? Just give me yes in the chat box so that we can proceed further. Fantastic. Super. Now understand this. This is the same data. That's why the same X bar. What is X bar? X bar is nothing but the mean of the data. Okay. And there is something very interesting called UCL. Okay. Write down the formula for UCL. UCL equal to X bar plus 3 times standard deviation. And there is something called LCL here. What is the formula of LCL? X bar minus 3 times standard deviation. Write the formula down. Write the formula down. Okay. Okay. Now just understand this. Imagine I will just give you with this formula. I will just give you a simple equation. If X bar is 42 and sigma is let's say 2. If X bar is 42 and sigma is 2, can you calculate UCL and LCL with this formula? Type in the chat box. Calculate this and type in the chat box quickly. Very good question, Rajiv ji. I will answer this question. And ये answer बहुत बड़े लोगों को पता नहीं है. Anyway. Yes, X bar is 42 and sigma is 2. What will be my UCL and what will be my LCL? Everybody type in the chat box. So x bar is 40. Let's put it in the chat, put it in this formula. X bar is 42 plus 3 into standard deviation is 2, right? So 42 plus 6 is equal to 48. So UCL is 48. Everybody got 48? Similarly, x bar is 42 minus 6 is equal to 36. So UCL is 36. So UCL is 36. Sorry, UCL is 48 and LCL is 36. Everybody got it? Any question? No, right? Now, according to the father of statistical process control and the control chart, Walter Shewhart. Okay. He says any process. Okay. Yeah, the full form of UCL is upper control limit. Write this down. Upper control limit. And the LCL is lower control limit. Everybody, upper control limit and lower control limit. Everybody got it? Just type yes in the chat box. Upper control and lower control limit. What is the formula? I have already given you the formula. Okay. Now, the question Rajiv ji has asked, why the 3 standard deviation? And this was the question asked by one of the interviewer in the interview. Okay, very good question, by the way. According to Walter Shewhart, okay, any process which runs between +3 and -3 standard deviation is called a stable process. What is stable? Stable meaning predictable process. The behavior is predictable. Okay, so any process which flows between +3 and -3 standard deviation, it's called a stable process. Now, why stable process? And why +3 and -3? After a lot of permutation and combination, Walter Shewhart, now this is the example, just understand this. There is something called, write this down, alpha error and beta error. Now you will not understand this, but the answer is this. At +3 and -3 standard deviation, okay, alpha error and beta error gets balanced out, and that is the reason basically Walter Shewhart decided, let's fix this level at 3 standard deviation. If you go to 4 standard deviation or 5 standard deviation or 2 standard deviation, this alpha and beta balance actually gets disbalanced, and that's the reason he finalizes at 3 standard deviation, which basically all the statistician fraternity finally applauded and gave the approval for this. Okay, so for us, what is alpha error? What is beta error? Okay, so this is something which will require another couple of hours to explain this. Okay, I will touch upon this topic in the hypothesis testing in the second half today. Okay, just touch upon that a little. Okay, so the answer is it balances out alpha and beta error at the 3 standard deviation. Okay, yes, correct. So in the MBB class, this was explained. All right, now. No. UCL and LCL are different and USL and LSL are different. Okay, I will explain you that. Clear? Yahan tak clear hai everybody? Just type yes in the chat box. Okay, so these, just type yes. Okay, very good. Now these data points which are between these 2 control limits are called as, write this down. Okay, these are called as common cause variation. Write this down. Common cause variation. The data within the control limits are called common cause variation. And any data which goes beyond this control limit are called as special cause variation. If any data goes beyond this, like this, It is called special cause. For example, your office arrival time. Okay. Every day you come 5 to 10 minutes up or down, right? Yes or no? Some variation, 10, 15 minutes variation is there. So it's called common cause variation. What is special cause? One day, if there is an accident on the road or your tire got flat, okay, that day you reach 1 hour late. It is called special cause variation. Are you understanding how to identify? A special cause you can easily identify if it goes beyond control limits. It is called special variation. Are you clear? Just type yes in the chat box. Clear, everybody? Yeah. So any data, any variation within the control limits, upper control and lower control limit is called common cause variation. And any data point which goes beyond control limit is called special cause variation. Simple. Okay. An example I have given you, a special cause like a special, okay, while coming back, you came late because your car broke down. It was a special cause. That's why you came 1 hour late. So that data point will be going out of control limit. Or other variation which are common causes, 5 minutes, 10 minutes, 15 minutes delay or early, that variation is called common cause variation. Clear? Just type yes in the chat box. So this testing is called as stability testing. This test is called stability test. Clear hai everybody? Now, this is something very interesting. Now, note this down, okay? Once this stability test is done, then we'll go to SNC. This is stability. Okay, so only one data point is at a boundary level of UCL. Otherwise, all the data points are within this. Okay, so more or less this data is stable. Then we go to the normality test. So go to stat, basic statistics, normality test. Stat, basic statistics, normality test. Okay, go to stat, basic statistics, normality test. Everybody with me? Stat, basic statistics, normality test. In the variable, select chocolate weight and say, okay, don't do anything else. Everybody got this? Just type yes in the chat box. Very good. Now, without going into the detail, this is called AD test. You can see here AD. AD stands for Anderson-Darling normality test. These are two statisticians' name has been given. Theodore Anderson, A for Anderson and D for Darling, Donald Darling. Theodore Anderson and Donald Darling. These are the two statisticians the name has been given. Okay. We are interested in, this is all the same thing. The mean is the average, 42.11. Standard deviation, we have already seen, n is equal to number of data points. AD value does not have any meaning to us. What we are interested in this value, P value. P value stands for probability value. Okay. If P value is greater than 0.05, then the data is normally distributed. Write this down. If the P value is greater than 0.05, then the data is normally distributed. If the P value is less than 0.05, then it is a skewed distributed. Are you clear? Just type yes in the chat box. Normally meaning symmetrical distribution, skewed meaning unsymmetrical, non-symmetrical. Clear? One side skewed. Just give me yes in the chat box. Now, we have already done this exercise. Okay, I will explain you this. From where will you get this? Go to stat, basic statistics, normality test. Stat, basic statistics, normality, the third last. In the basic statistics, third last option is normality. Okay, click on that. Just select the chocolate weight and just click on OK. That's it. And you will get it. Now, what I said, we have already done this analysis in our first graph. I will show you that. Okay. Look at this graph, guys. Now, let me just open. Do you remember this graph? Okay. Now, somebody asked me the first two lines here. I think it was Rajiv ji or somebody asked me, okay, what is the meaning of the first two lines? This is exactly the same. Yeah, Sachin ji had asked me, yes. This is, if I would have explained you then, it would be a bouncer at that point in time. Now you can see here the p value 0.256 and AD value, which is 0.46, the same thing. AD value or A square value, same thing. Okay. So this is a normality test. Are you clear? So N for normality. If the data is normal. Now, is it normal? Is it greater than 0.05? Yes, it is 0.05 से ज़्यादा है, which is 0.2. Correct? Is there any maximum limit to p-value? Yeah, so the p-value should be 0.05. It is greater than 0.05, then it is normal. If it is less than, then it is non-normal. Okay. Now, what is this p-value? I will explain you after the break. Okay, clear hai? So normality clear hai yahan tak? Just type yes in the chat box. Is normality clear? So we have done the S, stability. We have done N, normality. Yeah, what to do if the p-value is less? I will explain you. Okay, so that we will handle in the black belt level. It is called something, it is called transformation of the data. If the data is non-normal or the skewed data, then there is something called transformation basically we do. Clear hai? Okay. So which we will cover in the black belt level. Now let's go to the next one. It's called C for capability. Now for the capability, go to stat, go to quality tools, capability analysis, normal. Stat, quality tools, capability analysis, normal. Everybody follow this. Stat, quality tools, capability analysis, normal. Why normal? Because the data is normally distributed. All right. Just click on that. Now select the chocolate weight here. I'll just repeat once again. Just follow with me very slowly. Stat, quality tools, capability analysis, normal. Okay. Now once you click on normal, this window will appear. Now just select the chocolate weight in the single column here. Okay. In the subgroup size column, just select the sample. Double click on the sample. That will get selected. In the lower specification limit, now here we have to decide what is the specification limit. Just put 36 grams. And the upper specification limit, just put 48 grams. Okay, just randomly I'm giving you the limits, specification limits. Specification limits are decided by the customer. Okay. So lower specification is 36, upper specification is 48. Don't click on OK yet. Go to option. And on the option, you can see benchmark Z. Can you see here benchmark Z or the sigma level? Okay, just click on that. Just click on that. Go to option. You will find this. Okay, option yahan pe hai. Can you see here? Yeah, upper hai 48. Lower is 36. Upper is 48. Then go to option. Instead of capability stats, select benchmark Z and say OK. And say OK. Everybody got this diagram? Fantastic. So if you see this value, Z bench, this value, done. This is 3.52. Everybody got this? So right now my process is 3.52 sigma process. This is my process capability number. After option, click on, I'll go back again. I'll go back again. So here in the option, I will select the Z, click OK, and just click OK. I will get this. Here, option में Z को click करो. Z पे click करो and click on OK and click on OK. Okay. Yeah. So this, when my Z score is 3.5, that means it is 3.5 sigma process. If this would be 4, it will be a 4 sigma process. If this would be 6, it would be a 6 sigma process. How many of you got this? Just type yes in the chat box. And this is called process capability analysis. Shantanu ji, I will touch upon your topic. Control limit and specification limit I will touch upon. ये clear हुआ? यहाँ तक clear है? Just type yes in the chat box. This is called process capability analysis. Okay? Super. यहाँ तक clear है? Yes. What do you want me to repeat? What you want me to repeat? Why there is are 2 standard deviations? Where are 2 standard deviations? Okay, overall and within. Now I'll explain you. Okay, so there are a lot of questions. Okay, a lot of questions. So let me just cover one by one. Okay. Now let's go back to the data. First, understand the data. Let me just remove this. First, understand the data. What is the data? Imagine. Now let me first explain the data and then I will explain you one by one. Okay. Imagine a chocolate manufacturing is happening. So chocolates are coming out of the factory. Okay. And I am the quality check person. Okay. So what I'm doing here is I'm taking, now there are small chocolates, right? So I'm not taking only one chocolate. I'm taking bunch of chocolates. I'm taking 10 samples. Here you can see here. Yeah. So I'm taking 10 samples here in one bunch. Can you see here? So in one shot, I'm taking 10 samples. Okay. So I am taking 10 samples, 10 samples, 10 samples, 10 samples. Like that, I'm taking 12 times. So total, I have got 12 batches of 10 samples each. Have you got it? Just type yes in the chat box. यहाँ तक समझ में आया the way I have done the sampling? Everybody got the sampling? Now, every batch, every sample, there is a within variation, yes or no? Within the sample, within the 10 samples, there is a small variation that is called within sample variation. Are you understanding? So every sample has got within sample variation, yes or no? It will be a smaller variation, but it will be variation. Now, if I mix all the 120 chocolates together, that will be a overall variation. And so there will be, if I draw, so this will be within sample variation like this. Okay. And the overall variation. Are you understanding? If I mix all 120 chocolates together, there will be overall variation, which will be a bigger variation. Clear, everybody? So within and overall. Within meaning within sample and overall meaning overall if I mix everything. Clear? Just give me yes in the chat box. Now the same is reflecting over there. The same is being reflected over there. Can you see here? Overall and within capability. Clear? Yes. So right now what we are doing is we are taking a sample average. So that's why we are taking this within wala average. So within. Overall also there is no much difference. Okay, 3.52 and 3.46. Not much difference. Okay. That means there is no much difference between sample to sample. Clear hai? Okay. So the whole diameter is 0 to 8. So 0 is lower and 8 is upper. USL is 8. Now UCL and LCL depends on the standard deviation. Shantanu ji, UCL and LCL depends on the standard deviation. Okay. Clear hai? So what I will do, I will explain you the difference between standard deviation, the UCL and USL. Okay. Now what we will do, let's draw the line. Okay. Let me go back to my whiteboard. Okay. First clarify this point and then we'll take a quick break. Okay. First, let's clarify this point. So just make a note on one part. just make a specification limit and then make a partition like this, and here you type control limit. Okay, draw this. Now specification limits are called as upper specification and lower specification limit, and control limits are called as upper control limit and lower control limit. Everybody? So within standard deviation is an average value. Within standard deviation is average value of all the standard deviation of the samples. Uska average hai wo. Okay, that's called within standard deviation. So standard deviation of one first sample, second sample, third sample, uska average. Okay, very good. Now specification limit, upper and lower. Now who decides specification limit? Customer decides. Write this down. Customer decides specification limit. And who decides control limit? Process decides the control limit. Okay, so specification limits basically are derived from voice of customer, and control limits are derived from voice of process. Specification limits, we use histogram. You remember we have drawn the histogram and then we have put the specification limit like this, correct? And here control limits, we draw control chart. So control chart, you remember like this, we have drawn the control chart like this, correct? Everybody? So these are the differences between specification limit and the control limits. So anything which goes beyond specification limit, is called defect. Anything which goes beyond control limit is called special cause variation. Clear? Just type yes in the chat box. Now, are you clear the difference between specification limit and control limits? And there is no connection between these two limits. They are interdependent from each other. They are not dependent. Specification limit is depending on customer requirement. Control limits are depending on the variation of the process. Okay? Amazing. Now so this is where the measure phase ends, where we find out the the sigma level of the process. Okay. So this is the end of the measure phase. Then we go to the analyze phase. Okay. Yes. So Z is calculated 3.54. Now that is called the Z. Now. So this is a Z. Okay. So this is nothing but a Z. This Z bench 3.5452 is called a Z score. Okay. So right now my Z score is 3. That means my process is 3.5 sigma process. And I want to actually go to the next level. Okay. Yeah, the Z ka formula, basically the Z ka formula is USL minus X bar divided by the standard deviation. Okay, upper specification limit minus X bar divided by standard deviation. Okay, so you can calculate this Z. Clear, everybody? So let's take a quick break and we will be back by 8:50. Okay, 8:50 ko hum log wapas aayenge. Yes, sharp at 8:50. Clear? Just take the break. Any question you have, you can. We will continue discussion further. Okay. Yeah. So the formula is. So I will write the formula here. Okay. Super. Yes, we are live on YouTube as well. Yes, absolutely right. So you can subscribe to the channel. If you have not subscribed yet, give the thumbs up, share that, with your friends, colleagues. If you want to refer, it's the best way. All right. Amazing. Chalo, let's take a quick break. And once we are back, just type I'm back in the chat box. We'll be back at 8:50 sharp. Okay. Chalo. All right. If you are back, just type I'm back in the chat so that we can continue. Everybody, I'm just waiting for your response. Once you are back, just confirm that I'm back. All right. Chalo, let's begin. Super. Now, when you will basically practice this, okay, you will come across a lot of questions. Okay. And that is what I am actually expecting. All right. So what I would expect, please collect your own data and do this stability, normality, and capability with your own data if you have a continuous data with you. Okay. So if you have the continuous data, please do this. And wherever you get stuck, okay. So if you're doing something and you get stuck, what should you do immediately? आपको क्या करना है? Wherever you get stuck, type in the chat box. Let's say you are doing something on Minitab and you get stuck. What should you do? Yes, everybody. I'm asking to everybody. All the new members, senior members. Yeah. Consult. Exactly. There is a number given. No, you can watch the recording and you can do the self-learning. The best and the fastest way of the support given is this WhatsApp number. Okay. So this WhatsApp number is with the mentors, including me. All right. So, but this is not for calling. This is just for the WhatsApp messages. Okay. So wherever you get stuck, this is a number, is your helpline number. Clear, everybody? Yes, just take a screenshot of, let's say you are doing some Minitab analysis and you stuck somewhere. Just take a screenshot, send it on this number. If if you are struggling with struggling to type, you can just simply send a voice note. That will also do the solve the purpose. Okay, clear? Chalo, let's आगे बढ़ते हैं. Now let's enter into the analysis. Okay, once we identified the process capability of the process. Now, why do we identify the process capability? We identify the process capability because we want to compare the after improvement. Okay, the process capability after improvement, if you want to compare, then we can compare that. That is the reason why we are basically, doing this process capability analysis. All right. So, super. Now, what needs to be done? Just try to understand this. Okay. In the analyze phase, just write this down. Everybody is aware of y is equal to function of x. Y is equal to function of x. Are you aware of this? Just type yes or no in the chat box. Everybody is clear. Anybody does not know y is equal to function of x, where y is output, x is input, right? Remember that? I explained you earlier as well. Now, our define and measure phase basically is dedicated to our output, our y, whereas our analyze, improve, and control phase are dedicated for our x's. Just make a note of this. This is a very important insight. Okay. So define and measure phase, we focus on our output, which is y, and analyze, improve, and control, we focus on our inputs, which contribute to our output, which influence our output. And that shift is happening right now with the analyze phase. Are you clear? So we are entering into the analyze phase. Now we are entering into the causes and the root causes of the problem. Okay. Now in analyze phase, there are two doors you will get. Okay. The first door is called the lean door, because ours is a Lean Six Sigma project, right? Lean Six Sigma methodology we are learning, right? So there are two approaches here, a lean approach and a Six Sigma approach. Okay. Is there any relationship between PDCA and DMAC? There is, because the DMAC is based on the PDCA cycle. The PDCA is the root cycle of lot of methodologies, not only DMAC. There are a lot of methodologies which are basically CAPA. What is CAPA? Corrective and preventive action. It is basically PDCA. DMAC is basically a PDCA. Okay. So lot of methodologies are like that. Okay. There are so many things, quality circle methodologies. Okay. Kaizen methodologies. There are so many methodologies. The root is on the PDCA only. Okay. Coming back to Lean and Six Sigma. So Lean way is called as the process door. You can just make a note of this. The process door approach. Process door. Okay. And the Six Sigma approach is called as the data door. Okay. I'm not visible, is it? Is my screen visible? Am I visible to everybody? Just give me yes in the chat box. Okay, screen is also visible, right? Yeah, Sanjeev ji, can you just check the internet connectivity एक बार, नहीं तो फिर log out करके फिर से log in करिए. That will be better. Now again, it depends on everybody's, what you can say. If you're on laptop, desktop, or you are on, mobile phone, it depends on the setting. So you can just change the setting accordingly. Okay. Super. Now, one is the lean is the process door. The Six Sigma is called as a data door. Write this down. Data door. So it's like after we enter into analyze phase, there are two doors here. Okay. One is the lean door. Other is called Six Sigma door. See, whenever we have a time related project, just try to understand this time. What do you mean by time? Time meaning, cycle time, lead time, downtime. Whenever there's a time association, okay, generally we use some lean tools over there. Are you understanding? Whenever there is a time association, lead time, delivery time, downtime, cycle time, takt time, all these concepts are there. So the lean approach is used. Okay, so lean talks about the time related projects, plus whenever inventory related projects, inventory reduction, whenever you have the waste reduction project, the waste, which is 7 West, Teamwood, everybody knows, right? On the other side, Six Sigma related projects are where the defect rejection, okay, rejection and defects related projects are there, then Six Sigma tools will be more handy. Okay. Now, coming back to the process door. So what tools generally we use? We use value stream mapping, VSM, or process mapping. Write this down just for our understanding. Okay. VSM is value stream map, then process map. Okay. So in our green belt level and the black belt level, it is given in details. What is value stream map? What are the 8 steps to construct the value stream map? Everything. Okay. And what is process map? Now, so these are two various ways. Apart from that, we do value added, which is called VA and NVA analysis. VA and VA analysis we do in the lean door. Apart from that, we do Teamwood analysis. Everybody know Teamwood, right? Everybody knows Teamwood. We have covered it in the even yellow belt as well, right? Transportation, inventory, motion, waiting. So all these are called the lean door approach. Clear? Okay, just make a note along with me. Okay. And on the other side, the Six Sigma, the data door approach, what tools do we use here? So we use fishbone analysis. Fishbone, followed by root cause analysis, RCA. Write this down. Fishbone is nothing but cause and effect. Okay. Everybody knows cause and effect, fishbone, man, machine, method, mother nature. Yes or no? Everybody remembers that? Clear? Then we have done the why analysis, root cause analysis. Remember that examples we do. We check about the Juran Institute, correct? The statue, the Jefferson Memorial statue. Remember that video we show on the yellow belt session? How many of you remember that? Fantastic. Okay. So the fishbone and the root cause analysis. After that, there is something called hypothesis testing. Hypothesis testing, regression. Okay, once we identify the root causes, we basically validate those root causes with these techniques. We generally validate those root causes with these techniques, hypothesis testing, regression analysis. There is something called DOE as well, which we will cover in the black belt level. DOE stands for design of experiments. This is also very powerful analytical tool we have. Okay. So as of now, in the green belt level, we will cover hypothesis testing and regression right now in the basic level. Clear, everybody? Just type yes in the chat box. Yes, Pareto also can be used in this validation technique. Yes, but because Pareto is already covered earlier, that's what I have not, put Pareto again. Yeah, so DOE stands for design of experiments. Design of experiments. Okay. And this is covered in the black belt level in detail, black belt and the master black belt level. So in the black belt level, basic DOE, and the master black belt level, advanced DOE is covered. Okay. Done, everybody? Done, done, and done. Iska screenshot le lo. If you have not written it down, just take a screenshot quickly. Now, because see, I would expect you to go through this process mapping, VA, NVA, Teamwood, and some of it we have already covered in the yellow belt. Okay, Teamwood we have covered, fishbone, RCA, root cause analysis we have covered, right? I would like to put more focus on hypothesis and regression today. Done? Just type done in the chat box. Done, done, done. Super clear? Yes, very good, very good. Super. Chalo. Now let's come to hypothesis testing. Okay. Pehle hypothesis. Now, once we identify root causes and the root causes, okay. Do you remember the example of Sachin Tendulkar I always give in my yellow belt session? How many of you remember? Just type yes in the chat box. How many of you remember that example of Sachin Tendulkar? Okay, whenever Sachin makes the century, India loses the game. How many of you remember that example? Yes. But when we collect the data to validate, then we found that it is not the truth. The truth is something else. Okay, truth is not the same. Only 12 matches we have lost. In the entire era of Sachin Tendulkar, when Sachin made the centuries. Out of 49, we lost 12 matches. And for Virat Kohli also, we have seen that, right? We have lost 10 matches out of 50 centuries has made. So not much difference between these two legends. But still, there is one perception, one hypothesis says this. Okay. Anyways, coming back to hypothesis testing. Now, this is very interesting. Hypothesis testing, hypothesis meaning assumption. Okay. There are two types of assumption. One is called null hypothesis. Write this down. null hypothesis, which is denoted by HO. Okay, this is called statement of equality. Just make a note of this. Statement of equality. Okay. Statement of equality. So I will explain. Just write this down. The second one is called alternate hypothesis, which is called as statement of difference, which is denoted by HA, A for alternate. And this is called as statement of difference. So both are exactly opposite statements we are making here. First, write this down and I will explain you. Okay. One is null hypothesis, statement of equality, and other is alternate hypothesis, statement of difference. Okay, now what is this? Let's try to understand this. Okay. Imagine there are two vendors. Okay. There are two vendors we have. And both the vendors are at par as far as the costing is concerned, at par as the quality is concerned. Okay. Now we want to check which vendor. Okay. Now only point of comparison is the delivery time. So what I will do, I will take the delivery time of vendor A and delivery time of vendor D. I will take last 50 deliveries of vendor A, last 50 deliveries of vendor B, and I will find out the average. So average of A will be XA bar, average of B vendor will be XB bar. Okay. So I will plot this, the data, and I will check whether there is a difference in the mean. How much is the difference between these mean, XA bar and XB bar? What is the difference between these two? And this two, if this difference is a little more than the value. Now, this is very interesting. Okay. Everybody knows sample and population. Just give me yes in the chat box. Sample population, yaad hai aapko? Yeah, just give me yes. Clear? This is the population. So we take a small sample out of it. So sample is a subset of the population. Yes. Now, when we take the sample, okay, we cannot be 100% confident about the population behavior. Understand this? Huh? When we take a sample, because sample is a small subset of it. It is not 100% data, right? It's a small percentage of data. But when we collect, we cannot be 100% confident. But if we take certain sampling formulae, some sampling strategies. Okay. Now, for example, one of the very common strategy is square root of n. Are you aware of the strategy of square root of n? Let's say, for example, if you have made 100 pieces and you want to check what should be how many samples should I check? Just take the square root of that value. Let's say if that 100 pieces you have produced, just take the square root, which is 100 ka square root is 10. So check the 10 pieces, and on the 10 pieces, you can basically confirm whether this lot is proper or not. Are you understanding this? This is one of the strategy. Similar kind of strategies are used in the quality parameters, in quality control and quality assurance departments. All right. This is called sampling strategy, sampling formula. Now, if you are using this sampling formula, what statisticians say, you cannot be 100% sure, but you can be 95% sure. And this 95% is called as, write this down, confidence level. Confidence level. Now, when you are 95% confident about your prediction, about your inferential statistic about the population, there is a error, probability of 5%. And that error probability is called significance level. Write this down. Significance level. When you are 95% confident about the prediction about a population, you are 5% a little, what you can say, not sure, not confident about it. And that is called significance level. Okay, that is called error. That is a region of error where you can make the error, probability of making error. And this 5%, if you observe very closely, 5% is also called as 0.05. Now, how many of you, the bells have started ringing when I say 0.05? How many bells have started ringing? Just type me in the chat box. Where have you heard about 0.05? Abhi to suna tha na? Ah, yes. The p-value, the Anderson-Darling test. Now I got it. Fantastic. The p-value. The p-value is the probability of making error value. Okay, are you understanding now? Now you are connecting the dots. That's what I said. When I will explain you hypothesis, I will explain you this. Okay. Now understand this, very, very important. Now, when I collect the sample, I am not 100% confident about the population, but I'm 95% confident, I can say. But there is an error of 5%, which is called probability of making error. Okay. Now, what I do, I will collect the data. I will put the data in the Minitab, and Minitab will tell me the p-value. Okay. And I will use a rhyme. The rhyme is this. The rhyme is this. The rhyme is, write this down. P low, null, go. Write this down. P low, null, go, and type in the chat box as well. And ये पूरे hypothesis testing का सार है. This is the nichod of hypothesis testing. This is the summary of hypothesis testing. Okay, the most simplified version of the most toughest topic of the statistics right now. P low, null, go. Okay, it's like collect the data. So I will collect the sample, the vendor A's data, vendor B's data. I will put that in the Minitab, and Minitab will give us the p-value. Okay, and on the basis of the p-value, we have to see whether we have to accept the null hypothesis or we have to reject the null hypothesis. Now, whenever the p is low meaning when the p-value is lower than 0.05, okay, null go meaning reject null hypothesis and accept alternate hypothesis. Understand this. Whenever the p-value is lower than 0.05, reject null and accept the alternate hypothesis. Are you clear? Just type yes in the chat box. Very simple. Clear hai? Super clear? Just give me yes. Now what we will do? We will do something interesting. I will give you a file here. And I was so confused about the topic. Yes. So I'm just making it very simple. And in the black belt level, we will see how this p-value is manually also you can calculate. Manually also calculation कैसे होता है हम लोग black belt level में सीखते हैं. Okay, so don't worry. Right now at the green belt level, just feed the data, check the p-value and infer out of it. Okay, एक बार करके देखते हैं, then I will open up some more questions for you. Okay, can you just quickly open this file? Can you just open this file quickly? The file which has been given, which says 2 sample t-test. Okay, 2 sample t-test. First, we will understand what does it mean, and then we will perform the hypothesis test. We'll check the p-value and then we'll infer out of it. Okay. Okay, fantastic, Ranjan ji. Super. Your Zoom error has been resolved now. Very nice, very nice. Super. Okay, everybody open this file. The file is something like standard process and pilot process. Everybody got this file? Just give me yes in the chat box. Everybody's opened the file? Just give me yes. Yes, now similar to our sample A, vendor A and vendor B, here there are two processes data we have taken. Okay, let's do the two sample t-test. First, this is a hypothesis testing. Okay, now here the null hypothesis is saying, let's first write the null hypothesis. So HO, which is null hypothesis, will be X bar. So X bar S is equal to X P bar. Okay, X S bar, which is standard ka average, is equal to pilot ka average. Okay, then the alternate hypothesis will say X S bar is not equal to X P bar. Simple. Okay, are you understanding? So software will calculate the averages and it will basically calculate the p-value and give us the right p-value. Okay, let's do this. करके देखते हैं इसको. First I'll remove this. Clear? एक बार लिख लीजिए. X O, which is null hypothesis, is both are equal. Null hypothesis is always equal. Statement of equality. Okay, and alternative is they are not equal. Okay, so let's open. Go to stat. Basic statistics, 2 sample t-test. Just follow this. Stat basic statistics, 2 sample t-test. Okay. Once you are done this, let me know. Just click on this. Stat basic statistics, 2 sample t-test. Now, here in the drop down, it says both samples are in one column. Now, if both the samples are in one column, then you have to select this. But right now we have samples are in different columns. So we have to select each sample in its own column, right? Select the second option. Select the second option here. Now it will show sample 1, sample 2. In the sample 1, select standard process, and sample 2 select pilot process. Okay. Statement will always be both equal. Yes. For the null hypothesis will be both are equal. Alternate will be there is a difference. Okay. And that will remain standard. Nothing will change. Okay. Everybody. So drop down में second वाला option select करो. Each sample in its own column. Select that. Sample 1 में standard process. Sample 2 में pilot process. And click on OK. That's it. All right. Super. Look at this. So here in this, you would have got this value. Okay. Everybody got this? So यहाँ पे there is one sessions folder. इसमें आपको ये मिलेगा statistical analysis, right? Got it, everybody? Just type yes in the chat box. What we are interested in? Super. So standard process, n is equal to, there are 22 data points here, and the mean is 14.65. And pilot process 22 data points, the mean is 14.34. Okay. So X bar S is actually 14.65 and X bar P is equal to 14.34. Okay. Everyone got it? Now standard deviation bhi hai iska aur iska, right? So then they have selected this, and what we are interested in this value. Okay. In the in our what you can say, in the black belt level, we will calculate these values. Okay, we'll calculate this t value, and then we'll calculate p value, what is degree of freedom, everything will calculate manually. Everything will calculate manually, and then we will calculate this. Okay, so p value right now is 0.485. Okay, so p low, null go. Correct. So what is our inference? Is the p-value lower than 0.05? 0.05. Huh? Remember this, not 0.5. A lot of people make mistake here. Is the p-value lower than 0.05? The answer is no. P-value is greater than 0.05. So we cannot reject null hypothesis. So there is no, now understand this. This statement is the most important statement. Okay. There is no, write this down. Write this down. There is no statistical significant difference between the two averages. Write this down. There is no statistical significant difference between the two averages. Write this down. This is a technical right answer. Okay, now understand this. there is no statistical significant difference between these two. Now understand this, both these averages we have done, right? Okay, one is 14.65, other is 14.34. So mathematically, there is a small difference, yes or no, everybody? Mathematically, there is small difference, yes or no? Are you understanding this? Have you understood this mathematical difference to have, which easily we can identify? Then what are we calculating here in this p-value? Now understand this. This mathematical difference is nothing but our which statistics? It is our descriptive statistic. And now we are inferring about the population. If this is the difference between the sample, what will be the difference of the population? That is that p-value is telling us. If the p-value is telling there is no statistical significant difference, that means there will not be in the long run. In the long run also, both these processes, there will not be much statistical significant difference in the long run in the population. Are you understanding? Just give me yes in the chat box. Sample में difference छोटा है. In the long run also, there will not be statistical significant difference. Clear? Just give me yes in the chat box. So this is called the hypothesis testing. This is about inferring about the behavior of the population. That's what is so important for us. Are you understanding? Just type yes in the chat box. Clear hai? Yeah, the last lines are first, when the p-value is not low, okay, there is no statistical significant difference. Okay, now understand this. Sample, this is a sample of 22 data points we have taken for standard process and the pilot process. Okay, now the process is continuous. Process continuous. So it will deliver result for a month, for 6 months, for 1 year. Let's say 1 year data. 1 year data is a population data. Imagine that. Okay. So with this 22 data point sample, there is a small mathematical difference, and the p-value suggesting, okay, in the population also, this statistical difference is not significant enough. It is not statistically significant difference. That's why we can say that x bar s is equal to x bar p, xp bar. Clear? So there is no statistical significant difference between these two processes for the population. Clear, everybody? Just type yes in the chat box. Okay, super clear. Very good. This is called two sample t-test. Very simple. So whenever you want to compare two, okay, so let's say Rishabh Pant and KL Rahul. If you collect the data of Rishabh Pant, KL Rahul data you will collect, put it in this and check whether any statistical significant difference is there. Okay, this is very simple. Then let me just give you another one. There is something called one sample t-test. Okay, what is one sample t-test? Just open this file as well. There's a file named one sample t-test. Just open this. I will also open this. Now, when do we use one sample t-test? Whenever we want to compare one sample, one process with a standard. That is called one sample t-test. Okay, one process with a standard. Let's say, for example, the average of the batsman, you want to compare, let's say average, the BCCI has, has decided the average should be 40 runs. So that is a standard they have set. So they will take everybody's average and they will compare that average with a standard. That is called one sample t-test. Clear? Now let's open this file of one sample t-test. So here you can see, this is the weight data of 20 data points are there. Some weight is there. Okay. And the standard is, let's say 25. So 25 is the standard and this is the weight data. Okay. Now let's do one sample t-test. Okay. So how do we do that? Go to stat, basic statistics, one sample t-test. Everybody just follow the same. Just above the two sample t-test, you will find one sample t-test. Okay. Click on one sample t-test. Now here, it is only one column, right? So here, just select the weight. And here you need to select perform hypothesis test. So here you have to put a standard here. So standard would be 25. Okay. So standard would be 25. Let's click on OK. So here you will find the P value is 0.680. Again, the P is high. So there is no statistical significant difference between the average. Now you can see the average is 24.946. Can you see the average here? 24.946. And there is no much statistical difference between 24.946 and 25. Okay, that's why the P value is very high and it is not statistically significant difference. Okay, now let's change this. Let's change this. Let's go back to the data. Now, how will you go back to the dialog box? There is a short key called edit last dialog, or you can just press Control E. If you press Control E, you can come here, or you can just click over here. Okay, on this cursor. You can see here my cursor, Control Edit dialog box. Okay, click on here. Now, instead of 25, let's put 30 here. Let's put 30. That means my standard is 30. Let's check the weight is comparing to the standard 30. Okay, let's put 30. Say OK. Now you can see the P value is 0.000. Some numbers would be there, but it is very less than 0.05. That means when the P low, null go. When the P value is lower than 0.05, you have to reject null hypothesis. That means there is a statistical significant difference between the average and the standard. Are you clear? This is called one sample T test. Here hai, just type yes in the chat box. Here, very good. When we go to the advanced level, we will manually see how you can do it for, for one sample T test, two sample T test, pair T test, ANOVA, one sample Z test. There are so many things. Manually also you can calculate. But now we have software, just put the data, select the test and check the p-value and infer out of it. That's it. Okay. So this is what is hypothesis testing at the green belt level. Clear hai? Okay. Now there is another method of validating whenever there are two parameters which are basically impacting each other. One X impacting the Y. Okay. When there is X impacting the Y, okay, and both are continuous in nature, there is one method we use, and that method is called as correlation or regression analysis. Okay, let's quickly touch upon that topic today before we close the day, because I know today, how many of you are feeling this a little heavier today? Chota sa heavy ho raha hai. How many of you are feeling this heavier, a little heavier today? Honestly tell me. Yes, heavier, but interested, right? Yes. सुपर सुपर सुपर. तो चलो एक काम करते हैं आज, है ना, कि एक ये लास्ट का टॉपिक कवर करके देन वी विल क्लोज इट. ओके, सो दिस इज द स्कैटर प्लॉट. एक इतना कवर करेंगे. ओके, या कोरिलेशन एंड रिग्रेशन, there is a small difference between correlation and regression. Okay, I will explain you. चलो let's open this file. Let's open this file. ये लास्ट का टॉपिक कवर करेंगे, दो ग्राफ्स बनाएंगे. I will explain you this and then we will call it a day. Okay, I know because it is Minitab, statistics, graphs, so it becomes a little heavier. Okay, but doesn't matter. Whenever it is uncomfortable, we are learning something new. Write this down. Whenever we are uncomfortable, that means our brain is learning something new. Whenever we are, right now I'm not learning anything. I'm just learning how to give the training when you are tired. That's it. I'm not learning anything new. But the people who are struggling the most, they are learning the most. Understand this, okay? Very good. Open this file, please. Once you open the file, let me know in the chat that the file is open, and let me also open the file. Okay. The name of the file is called scatter plot. एक बार open करके just type opened in the chat box. Open. Now the file, let's try to understand the data here. The data is about a company which wants to basically check the performance of their annual profits and their L&D expenses. Okay, let me just share this. Yeah, chalo. So this is the file. Okay. This is a file which says, so they have taken 6 years data. Whenever they are spending, let's say, understand this. This is expenses on learning and development. Okay, लोगों को training development करने के लिए जो पैसा खर्च करते हैं company. So if they are spending 35 lakh rupees on the same year, they have got 4 crore profit. Okay. So they want to track, is there any relationship between my expenses on L&D, which is my people grooming, people giving technical knowledge, okay, communication skill, leadership skill, Lean Six Sigma, all these skills, and what advantage I'm getting on the profit. Okay, so they want to just test it. So we will do it. Go to stat. No, go to graph and scatter plot. Okay, go to graph and scatter plot. No, not stat. Okay, graph and scatter plot. Okay, select simple only and say click OK. Now here, understand this. What is X and what is Y? Here, is the Y profit? Just type yes or no in the chat box. यहाँ पे profit Y है क्या? Y is the output. Just type yes or no in the chat box. Is the output profit here? And input L&D expenditure? Or vice versa? Can you understand my question? In this example, Y is equal to function of X, right? So what is Y here? Is it profit Y? If yes, just type yes in the chat box. Output is profit, correct? And input is the expenses on learning and development, correct? Yes. जितना हम लोग expense कर रहे हैं, खर्चा कर रहे हैं, कितना profit आ रहा है? So profit is the output, correct? So here in the Y, just select the profit, and in the X, select the expenses on L&D, correct? And just say OK. And you will get these kinds of dots. Now, there are 3 kinds of patterns you will see over here. And this is called scatter plot. You can see here, this is called scatter plot. There are 3 kinds of, one is this kind of pattern. This is called positive correlation. Second is called this kind of pattern. It is called negative correlation. And the third one is called this kind of pattern, when there is no correlation. Okay, I'll give you example of positive correlation. Your time on study and your marks on the examination. Time on the x-axis and marks on the y-axis. That will be a positive. More you study, more marks you will score, right? More you study, more marks you study, more marks you score. Are you clear with this? This is called positive correlation. Are you clear? Positive. On the x-axis, the time you study, more hours you study, more marks you score. It's called positive correlation. Both are going positive. One is increasing, other is also increasing. Second, negative correlation. More time you spend on Instagram, Facebook, less marks you will score. Are you understanding? So your Instagram, Facebook, the time is increasing, your marks are dropping. So one is X is increasing, Y is decreasing. It is called negative correlation. Are you understanding? And no correlation meaning? No correlation meaning? What is no correlation? Example, let's say the traffic in Mumbai and your office arrival time in Delhi. There is no correlation. If I plot a traffic in Mumbai on x-axis, okay, every hour by hour, how many vehicles are traveling, and your office arrival time in Delhi, there is no correlation between these two. Are you understanding? Okay. So right now, what is this correlation? So the path is, once again, the path is go to graph, and the first option is scatter plot. Graph and the first option is scatter plot. Graph and the first option is scatter plot. So here the simple scatter plot. In the Y, select annual profit. X, select expenses. Okay. Is it positive or negative correlation? Type in the chat box, guys. Yes. Can you see a positive correlation? X is also increasing, Y is also increasing. Okay. So you can see a trend like this. Correct? You can see a trend going upwards. Correct? It is positive correlation. So this is called correlation analysis. It just shows whether it is positively correlated or negatively correlated, or whether there is no correlation. Okay. Now, there is another way which is called regression. Now, let me explain you regression quickly. Now, go to stat, regression, fitted line plot. Can you just click on this? Stat regression fitted line plot. Okay. Everybody, go to stat, regression fitted line plot. Just click on this. The same thing, select profit in the Y and expenses in the X and click on OK. Now, if you observe closely, yes, I've got basically two graphs here. Now understand this. Both are exactly same graph. This is correlation and this is regression. The same graph, the same data, but there are three differences. What are the three differences? This is called line of best fit. Okay, which is a line passing through all the data points. Okay. The second is this R square value. Now write this down, R square value. Okay. If R square is between 0 to 35, that means it is called low correlation. The strength, it shows the strength of the relationship. R square shows the strength of the relationship. Okay. Between 35 to 65, it is moderate. And if it is 65 above, it is strong correlation. So in this case, it is 76% or 77%. So it is a very strong correlation between the expenses and the annual profit. Okay. So you get line of best fit, you get the R square value, and you get an equation. It is called a regression equation. The equation is called Y is equal to A plus BX. And Y is output, X is input, A is called as intercept. First, write this down. And B is called as slope. I'll explain you. Y is equal to A plus BX. Or some people call it as Y is equal to MX plus C. Both are same thing. Y is equal to MX plus C. You would have heard about this equation. Okay. Or Y is equal to A plus BX. Both are same thing. Okay. Now let's understand what is A. A is intercept. A is intercept meaning if I extend this line of best fit, what point it intersects the Y-axis, this is called the intercept. Everybody clear? If I extend this line of best fit, at what point this line intersects, this is called the line of best fit. So this point, minus 1.8 is called the intercept. And what is slope? What is slope? If now under this is very interesting, no? This is X, right? And this is Y. Okay. Change in Y with 1 unit change in X is called slope. Write this down. What is slope? The definition of slope is the change in Y with 1 unit change in X. Write the statement down. I'll explain you. Change in Y, change in the output Y with 1 unit change in X. That is called slope. It means if I increase my expenses by 1 lakh rupees, how many crore rupees I will get in the profit? That is called the slope. So which is 0.18. That means if I put 1 lakh rupees in my X, I will get 0.1883, which is 18.83 lakh rupees profit. How many of you got this? Just type yes in the chat box. This is called the slope. So if I increase the expenses, I will get this much of profit. So 1 lakh ka maine expense kiya, I will get 18 lakhs ka profit, almost 19 lakhs ka profit. This is called the slope. Okay? So this is called the regression equation. It shows the strength. And if you have the doubt, now if you want to validate whether the expenses are playing the role, so it is showing that yes, expenses are playing the role in your expense or learning and development are playing the role on your profit margin. Okay, so this is one of the factors. There are multiple factors which are playing the role. Okay, clear? So this is called correlation and regression. Are you clear with this? Just type yes in the chat box. Super clear? Don't say clear because it is too late now. Okay. Clear? सब पक्का समझ में आ रहा है कि नहीं है? Just check the recording once again. It will clarify it further. Clear? Okay. And again, give some time, especially the new people. It might sound a little, what I can say, heavier. Okay. Everyone can easily understand. Thank you very much, Rajiv ji, for this. Super. Yeah, see, and why I'm just explaining this again and again, because you guys, you guys will understand as you go to the yellow belt, to green belt, to black belt, to master black belt. Next, you become the mentor. Okay, so this is the way you need to explain it to other people as well. Okay, as a mentor, you need to be very patient. Somebody will not understand it completely even after 3 times as well. 4th time also, see, when you will become a mentor, the 4th time also, you will be a similar kind of patience you will show to explain this. Okay, and it is absolutely normal because these are the complex topics. Okay, so people understanding this is a little difficult. So we have to be a little patient, go very slow, step by step, and explain them. Okay, ठीक है? तो यहाँ पे आज रुकते हैं. Let's stop it here because it's becoming very heavier today. Okay. Yeah, ask were adjusted. हम लोग black belt में सीखेंगे. Okay, black belt में design of experiments में. Okay, fantastic. चलो, thank you very much for joining in. The recording will be available, in the green belt hackathon. Okay. सो ग्राफ को कैसे एक साथ रखना है वगैरह मैं सब कुछ सिखाऊंगा. ठीक है. फर्स्ट लेट्स गो विद द बेसिक लेवल्स. ओके, यहाँ पे आप देखो ग्राफ का एक ऑप्शन है. आई विल शो यू. There's a graph option. So on the left hand side, you'll see all the graphs. Okay, this is the scatter plot. This is the fitted line plot. Okay, so all the graphs get find out. Okay, on the left hand side, if you click on the graph button, you'll see on the left hand side all the graphs. You can click on them and you can show it to them. Okay, super. Thank you guys. Thank you very much. So keep learning, keep growing. Good night. We'll see you on the day 3 tomorrow with the same enthusiasm. Till the time. Good night. Take care. Bye bye. It's a multiple choice, Nagaraj ji. Yeah, MCQ type.